Question number 15. Identify the type of waves which are produced by following way and write application. कौन सी वेव पैदा होती है इस एक्शन से और उसका एप्लीकेशन क्या है? तो इसे पहचानिए. वेव्स का टॉपिक कौन सा है? इलेक्ट्रोमैग्नेटिक वेव. और उस इलेक्ट्रोमैग्नेटिक वेव में दो चीजें हमको पता करनी है. प्रोड्यूस्ड बाय द फॉलोइंग वेव, किस प्रोसेस से कौन सी वेव पैदा होती है और उसका एप्लीकेशन क्या है. तो ये एक चार्ट हमने याद किया हुआ है. उस चार्ट में हमारे पास है प्रोड्यूस्ड बाय, और उसके बाद एप्लीकेशन. प्रोड्यूस्ड बाय और एप्लीकेशन, ये दो चीजें हमने इसमें करनी है. तो इसमें फर्स्ट है रेडियो एक्टिव डिके. रेडियो एक्टिव डिके में अल्फा पार्टिकल, बीटा पार्टिकल और गामा रेज, ये तीन चीजें पैदा होती हैं. इसमें रेडिएशन या वेव कौन है? तो आंसर है गामा वेव्स, और द गामा रेज आर दी number 1. So number 1 answer gamma rays. Okay, now number 2, rapid acceleration and deceleration of electrons. Rapid acceleration and deceleration of electrons in aerial. ये एरियल हमें बताएगा कि अगर उसमें एरियल में एक्सेलरेशन होता है इलेक्ट्रॉन्स का तो कौन सी वेव निकलती हैं. ये हम पढ़ चुके हैं. ये होती हैं रेडियो वेव्स. सो सेकेंड आंसर विल बी रेडियो वेव्स. Third, bombarding of metal target by high energy electrons, और इसका आंसर हम सबको मालूम है एक्स-रेज. Bombarding of metal by high energy electrons. अब इन तीनों के एक एक एप्लीकेशन भी हमको लिखने हैं. So this is our answer, first part. This is our answer, second part. And this is given. Okay, now second part. We know what is X-ray used for. Medical, industry, to check cracks, fractures. Radio waves, communication, and one example of communication is television. Gamma rays, these are used to find out the nucleus structure in nucleus physics. As well as we are using it in medical purpose. There are some other uses also. These are not the limited. There are many other uses. You have read the complete chart. उसके अनुसार आप अपना आंसर तैयार कर सकते हैं. So this will be answer 1. Answer 2. This is a 3 marks question. So half, 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 half. There will be 3 marks like this. And now we go to the next. Okay. See this question, two slit interference arrangement. This is S1, S2, S1, S2. These are the secondary sources. There is a screen. The screen is half the distance between the slits. Slits S1 और S2, इन दोनों के बीच का डिस्टेंस हम मान लेते हैं D. तो ये वाला D स्क्रीन कितनी दूर है? आंसर है दिस स्क्रीन D is half the distance between the slits. D is equal to D by 2. अगर ये इसका सेंटर है C, तो ये वाला डिस्टेंस कितना है, d/2, और d/2 किसके बराबर है, d के बराबर, इसलिए ये वाला डिस्टेंस भी d हुआ और यहां से ये डिस्टेंस भी d हुआ. ओके, नाउ obtain the value of d in terms of lambda such that first minima on the screen falls at a distance d from the center. O, ये स्क्रीन का सेंटर O है, यहां से d हाइट पर जाकर फर्स्ट मिनिमा बनता है, d हाइट पे जाके फर्स्ट मिनिमा. ये डिस्टेंस d, पर हमको मालूम है ये डिस्टेंस भी d है, तो ये दोनों इक्वल हाइट पे आ गए. ठीक है. नाउ दिस पॉइंट इज P. S1 से एक वेव चलेगी एंड दैट वेव गोज टू P बाय दिस पाथ. S2 से एक वेव चलेगी और ये यहां से आई बाय दिस पाथ. दिस S2P इज द पाथ लेंथ फ्रॉम सोर्स S2 and S1P is the path length from source S1. How much is the path difference? The answer is path difference is S2P minus S1P. How much this should be for first minima? The answer, first minima, this path difference should be lambda by 2. This should be the path difference, lambda by 2. Okay, now we have to find out the relation between lambda and d. D in terms of lambda. Okay, so we will take help of geometry here. First, S2P square is equal to, see here, S2P square. I make a triangle here. This distance is d, this distance is d, this distance is d. So how much is S2P square is equal to d square plus 2d square. So this is d square plus 2d square, which is equal to 2d square, which is equal to 5d square. Therefore S2P is equal to root 5 into d. This is S2P. Now S1P. S1P square. This S1P is equal to d, simply because this is d, this is d, this is d, these are 98 degrees, so this has to be equal to d. So S1P square is equal to d square, or we can write S1P is equal to d. Now this path difference S2P minus S1P, S2P minus S1P should be equal to lambda by 2. So we can write root 5d minus d should be equal to lambda by 2. So therefore lambda is equal to 2d in the bracket root 5 minus 1. Root 5 minus 1. This is the relation between lambda and d, the value of d in terms of lambda. This we can find it. Okay, the value of d in terms of lambda, lambda upon 2 root 5 minus 1. This is the answer. Okay, so this is how we get the answer for this. ये हमारे क्वेश्चन का डायग्राम देखिए, एक कंपाउंड माइक्रोस्कोप में दो कॉन्वेक्स लेंसेज हैं. कंसिस्ट ऑफ एन ऑब्जेक्टिव ऑफ फोकल लेंथ 1 सेंटीमीटर. इसकी फोकल लेंथ, ये इसकी फोकल लेंथ है यहाँ तक, एंड दिस फोकल लेंथ इज 1 सेंटीमीटर. ओके, eyepiece has focal length 5. Eyepiece has focal length 5 सेंटीमीटर, यहाँ से लेके यहाँ तक या यहाँ से लेके यहाँ तक. ओके, Now the distance between them is 12.2. इन दोनों के बीच का distance 12.2. At what distance from the objective should an object be placed? इस ऑब्जेक्टिव से ये ऑब्जेक्ट हमको रखना है. हमारा नॉलेज ये कहता है कि ऑब्जेक्ट हमेशा माइक्रोस्कोप में फोकल लेंथ के बाहर रखा जाता है, अवे देन द फोकल लेंथ. सो दिस इज ऑब्जेक्ट, दिस इज द डिस्टेंस UO. एट व्हाट डिस्टेंस? सो दिस इज अवर क्वेश्चन नंबर 1. ये हमको निकालना है. गिवन क्या है? So that the final image is formed at least distance of distinct vision. This is least distance of distinct vision. D. यहाँ पर final image बनना चाहिए. Okay. Second, calculate angular magnification in this case. Okay. Magnification, angular magnification हम निकालेंगे. Right. So first हमें UO की calculation करनी है. हमको एक फॉर्मूला मालूम है, 1/v minus 1/u is equal to 1/f. दूसरा हमको मैग्निफिकेशन का फॉर्मूला मालूम है, that is v/u 1 plus d/fe. This is for magnification for distinct vision. Okay. First this thing 1/v minus 1/u. अगर हमको ये u निकालना है तो हमें क्या क्या चाहिए? U निकालने के लिए we need V and we need F. ऑब्जेक्टिव, ऑब्जेक्टिव, ऑब्जेक्टिव. तो हमारे पास क्या इसकी फोकल लेंथ है? आंसर है yes, we have it. 1 centimeter. This is known to us. Do we have V? यहां से इसकी इमेज यहां पर बनती है, फर्स्ट इमेज, और इस इमेज को ये मैग्नीफाई करके डिस्टिंक्ट विजन पर बनाता है. ये हमने पढ़ा हुआ है. लेकिन यहां से यहां का जो डिस्टेंस है, दिस डिस्टेंस विच वी कॉल V फॉर O, इमेज डिस्टेंस फॉर ऑब्जेक्टिव, इट इज नॉट गिवन टू अस. इफ इट इज नॉट गिवन टू अस, वी हैव टू फाइंड इट. ये डिस्टेंस 12.2 है. ओके. अगर हमको ये मिल जाएगा तो हम इसको निकाल लेंगे. अब इसको ढूंढने के लिए दिस मच वी नो 12.2. इफ वी आर एबल टू कैलकुलेट दिस डिस्टेंस, तो दिस डिस्टेंस वी कैन subtract from 12.2 and we can get this distance. So now our target change, we want to find out this distance. ये distance इस lens से related है. What is this distance for this lens? Answer, it is UE. So here again we have for UE, see 1/VE minus 1/UE. 1/VE minus 1/UE is equal to 1/FE. This we can solve. And do we have the data for this? So this V, ये है इसका V, D के बराबर, और इसकी वैल्यू हमको पता है, this is 25 centimeter. Now if we have this 25 centimeter minus this we have to find out, and 1/FE, this we know it is 1/5. All are in centimeters. So this gives us, by solving we get answer UE is equal to minus 4.2. This is UE. If we have this UE here, then we can find out this distance. And what is this distance? V for the objective. So V for the objective is equal to 12.2 minus 4.2 is equal to 8. Now this VO we will use here. So this is 1/VO, that is 8 minus 1/UO is equal to 1/FO 1 upon FO, and FO is 1. When we solve this, and we get this solution, and this comes out to be minus 1.1. Minus 1.1 centimeter, and this is our answer for UO. Okay, this we got. Now the second part, calculate angular magnification. Magnification, we have the formula for magnification, that is V objective U objective 1 plus D upon FE. Okay, now we have all the values here. V objective is here, V objective 8 upon U objective minus 1.1, 1 plus 25 upon 5. FE is 5. And when you solve it, you will get the magnification, and this magnification comes to be 44. Approximately 44, and this is negative. So this is the magnification. Whether it is linear or angular, the value will be same. So this is how we can find question number 17 done. Now we go to the next question, that is question number 18. See this question, read it out. It's a 3 marks question. We are supposed to reply it in 3 parts. The first portion will be, it's totally theoretical question. In first part we will explain what is photoelectric effect. Explain what is photoelectric effect. Second, explain how particle nature can eject electron with features of stopping potential. ये आपने थ्योरी में पढ़ा है कि फोटोन एक पार्टिकल जैसे जाकर जब हिट करता है, एक इलेक्ट्रॉन को निकालता है, उसके पास जो एनर्जी होती है, दैट एनर्जी इज इक्वल टू ई वी नॉट, एंड देयर वी नॉट इज द स्टॉपिंग पोटेंशियल. ये तभी हो सकता है जब फोटोन एक पार्टिकल के नेचर में आए. वेव के नेचर में आए तो नहीं हो सकता. तो यही हम आगे एक्सप्लेन करेंगे कि वेव के नेचर में ये पॉसिबल नहीं है. थर्ड, wave cannot explain threshold frequency and energy of electron, kinetic energy of electron. Therefore, wave theory is a failure. तो मैं यहाँ पर आंसर नहीं लिख रहा हूँ, मैं आपको ये बता रहा हूँ कि आपने आंसर में क्या क्या लिखना है. तो आप पहले ये लिखेंगे, फिर ये लिखेंगे, फिर ये लिखेंगे, एंड दिस यू विल बी एबल टू मेक एट लीस्ट 12 sentences. So that will mark a theoretical question of 3 marks. सबको 3-3, 4-4 सेंटेंस में एक्सप्लेन करिए. That will be the complete answer. Now we go to the next question. ये question number 19 देखिए. Derive the expression for magnetic field at the site of a point nucleus in a hydrogen atom due to circular motion of the electron. Assume that the atom is in the ground state and give the answer in terms of fundamental constants. There is hydrogen atom, charge, one electron is moving around it. A moving electron makes an electric current, and an electric current in a circular path create magnetic field at the center. So because of this moving charge there is current, and because of that current there is a magnetic field here, and we have to find this magnetic field. Now the thing is that they want us to find out the magnetic field in terms of fundamental constants. Now what are the fundamental constants and what is magnetic field? Magnetic field due to electric current, we know the formula that magnetic field is equal to mu naught I upon 2r, where I is the current flowing in the circular path and r is the radius. This is the general formula. We know mu naught, we all know it is a constant. Now we have to state this in terms of constants. Here mu naught is a constant, but I and r are not constants. हम कौन कौन से constants को जानते हैं? There are many constants we know in this topic. Mu naught, epsilon naught, charge of electron, mass of electron, Planck's constant, और अगर जरूरत पड़ेगा anything else. Okay, but these are certain constants whose value do not change. So we need an answer for B in terms of all these. Okay, so we have to think of many equations. It's a wonderful, it's a very good question, and which take test of your memory, how many things you know. I and R, these two are to be eliminated and these are to be introduced. I is due to motion of this electron, the charge is E, and we have to find out, we have to convert it in terms of these. Now what are the other formulas we can take help of? Let's make it one by one, and I will take you to the green board. It is a long question. Okay, so I will make that diagram here once again. R, E, and here is charge placed plus E. We have to find out B, and this B I will write here. First B, this is mu naught I upon 2R. B is mu naught I upon 2R, and we have to find out value of I and R. Now I, current, we know that formula for current is charge upon time, passing through any cross section, and for electron we have already done it, that I is equal to Q upon time. Here this charge goes one round, so the charge quantity is E, and time, this total distance is 2 pi r divided by velocity v, so it comes to be E v upon 2 pi r. This E v 2 pi r is the value of current, where V stands for velocity. Okay. Now, this I we can place here. So this B is mu naught upon 2R, and in place of I we are going to write E V upon 2 pi R. So this comes to mu naught E V upon 4 pi R square. But it does not help much, क्योंकि अभी भी हमारे पास दो वेरिएबल हैं, V for velocity and R for radius. But anyway, we will write this B again as equation number 2. B is equal to mu naught E velocity upon 4 pi R square. This is equation number 2. Now we go on searching for equations for velocity and radius. One very important relation between the two is the force between these two and centripetal force. The centripetal force is mv square upon r, and this centripetal force is given by the Coulomb's force here, and quantity of Coulomb force, we are not taking sign, quantity of Coulomb force is 1 upon 4 pi epsilon naught q1 q2, that is E into E upon R square. This. Okay. Now we solve this, and this gives us 1 R is cancelled. We can find out what is the value of V square. V square. V square is 1 upon 4 pi epsilon naught, because we are searching for V and R. So anyway, V square is 1 upon 4 pi epsilon naught. 1 R is cancelled. So we have 1 upon 4 pi epsilon naught E square upon R. Okay, and this M will also come here. So let's write it M R. This is V square, and let's write it here. V square is equal to E square upon 4 pi epsilon naught M R. Okay. Do we have any other formula for V? Answer is yes. According to hypothesis, Bohr's hypothesis, we know that angular momentum of electron, MVR, this is equal to NH upon 2 pi. N is number of orbital, or we can say state. So it is given that it is in the ground state, atom is in its ground state, so this N will be 1. So here we have V is equal to H upon 2 pi M R. This is value of V according to Bohr's hypothesis. Why we want to go for this? Because this has a constant H, this has a constant mass of electron. So this is value of V. Now this is our equation number 4. H upon 2 pi M R. Now these two equations, this equation number 3 and equation number 4, these are going to help us a lot. देखिए, we can find out value of V and R in terms of constants. This 3 divided 4, V square divided by V. So we write it here, divide 3 by 4. And what we get here, V square upon V is V, equal to this upon this. I will write it 1 upon 4 pi epsilon naught MR this is E square E square. This was equation number 3 divided by equation number 4. So when we are dividing it, it comes to be 2 pi mr h. Okay. Now here, what is cancelled? E square upon 2 epsilon naught h. 2 epsilon naught h. This is V. So I write here again V is equal to E square upon 2 epsilon naught h. See the wonderful thing. Here everything is constant. Okay. Now we find the value of h. Value of r. To get that value, this is number 5. Now we want value of r. Again we take help of 3 and 4. Make it a square, eliminate with this v square. So what do we get here? Let's make it a square. H square upon 4 pi square m square r square. H square upon 4 pi square m square r square. This is v square, and this v square is equal to here E square upon 4 pi epsilon naught mr. 4 pi epsilon naught mr. This. Now here v square is eliminated and we can find the value of r. Okay, cancellation कर देते हैं. 4 is cancelled. Here is, okay, I will write it here again. So this comes to be h square upon e square. You can do it yourself. Pi square m square r square upon pi epsilon naught mr. Pi epsilon naught mr. I am doing it slowly so that we don't have any mistake here. So this is 1 pi is cancelled, pi. Here 1 m is cancelled, m. 1 r is cancelled, r. Here this is pi is cancelled, m is cancelled, r is cancelled, and we have it mr, and here is epsilon, and this is h square upon e square. So we get here the value of r. R is equal to epsilon naught h square divided by pi m into e square. Now this is our next equation. R is equal to epsilon naught h square upon pi m e square. Why we want this? We want this because in B we need value of two variables, velocity and radius. So we got it velocity, and here is radius. Now by equation number 2, equation number 5, equation number 6, 6. Okay, in this we place the value of V, in this we place the value of R. So we get here B is equal to, put both the values, do the cancellations, and what do we get here? रख के देख लीजिए. Yes, mu naught E upon 4 pi. These are the constants. In place of V, we are going to place E square upon 2 epsilon naught H. In place of 1 upon R square, 1 upon R square, epsilon naught square, H to the power 4, and this you put it here, this will be pi square m square e to the power 4. This. Now so many cancellations. B is equal to mu naught is there, e to the power 1, 2 and 4, e to the power 7. Okay, m, this is m, there should be one m in the denominator. Okay, this pi is cancelled and we have pi, mu naught pi. Mu naught pi. Mu naught pi m e to the power 4, 2, 6 and 1, 7 upon 4, 2 is 8, 8 epsilon naught to the power 1 to the power 2, epsilon naught to the power 3, and H here is 4 and here is 1, H to the power 5. And yes, m to the power 2, m to the power 2. So this is, now you see this, mu naught is a constant, pi is a constant, mass of electron, charge of electron constant, epsilon naught permittivity constant, and this is Planck's constant. So all the quantities are constant, and this is our answer, that B is equal to mu naught pi m square e to the power 7 upon 8 epsilon naught to the power 3 and H to the power 5. This is our answer for B, and now you see all are constants. So this is how it will be done. Now the thing is, how we did it? The answer is by memory and by remembering all the equations which you know. Therefore it's very necessary that you must remember all the equations by heart. Once I say velocity of electron, then all the equations connected to velocity of electron in an orbit should come to our mind. We have already done how much is the current, equivalent current of this. We have already done what is its magnetic field at the center. We have already done what is its angular momentum. So the same thing we have used here, and we got it this way, and now we got the B in terms of all the constants. Okay, now again we go to next question, that is question number 20. This question has got 3 graphs. I will make the graphs for you. These graphs are voltage. Okay, the question is the graph of potential barrier versus width depletion region for an unbiased diode is shown in A. This is A. This is a graph for potential barrier versus width of depletion region. This is graph A. In comparison to A, graphs B and C are obtained after biasing the diode. एक डायोड है, उस डायोड की हमने बाइसिंग की. डायोड बायस्ड. बायस्ड करने के बाद उसके रिजल्ट ग्राफ B, this is and graph C, same. This is potential barrier V and this is depletion layer width X. Okay, X V. The question is, yes, आपको समझ आ गया है. The question is, identify the type of biasing in B and C. यहाँ पर कौन सी बाइसिंग है और यहाँ पर कौन सी बाइसिंग है, ये हमको निकालना है. Here potential barrier height increase, potential barrier height has become less. So we are concerned with potential barrier. तो किसमें potential barrier कम हो जाता है, किसमें increase हो जाता है? आंसर है the potential barrier become less and finally it vanish when there is a forward biasing. And this potential barrier increase when there is a reverse biasing. So our answer, graph B reverse bias, graph C forward bias, now okay, this was question number 20. Now we go to identify the type of biasing B and C and justify your answer. Justify the answer, we have to give them theory. No, not this way. This is the depletion layer and here N type, P type minus holes, not plus, holes. These are electrons and here we get the positive potential and here we get the negative potential. This makes electric field which gives potential barrier. Now we will write here forward bias. We will write the theory here in forward bias. This is applied potential and therefore this decreases applied potential. This is induced potential. net potential induced minus applied. Therefore, level of barrier becomes less, because induced potential is the barrier potential. Now, in reverse bias, we will write here reverse. We will make the diagram here. P, N, and here we will have plus, here we will have minus, here we will have plus, P, and this is N minus. Make it here, write this explanation here, applied and this is induced. Induced potential, and what is this induced potential? Barrier. Is added by applied potential, therefore barrier voltage increase, and this is B, and this barrier less, this is C, and that is B. So this is the explanation. So this will constitute half mark, 1 mark, 1 mark, and there will be 3 marks answer for this. Okay, now we go to the next question, that is question number 21. Okay, question number 21, it's again a 3 marks question, and there are 3 parts. So we can assume that every one part has got 1 mark. First, in the active state of transistor, the emitter base junction act as low resistance, while base collector region act as high resistance. Explain. Now, it's a 1 mark. We must explain only in 2 sentences. In active state of transistor, the emitter base junction act as low resistance. Why? So, active state emitter base junction is forward biased, therefore resistance, forward biased. What happens to depletion layer? Depletion layer shrink, depletion layer पतली हो जाती है, therefore resistance decrease. ये हमने किसको कवर कर लिया? Junction act as low resistance, base collector region act as high resistance. ठीक इसका उल्टा लिखिए. अगर ये पार्ट A है तो 1 का पार्ट B क्या होगा? That will be base collector. Base collector is reverse biased. Hence, resistance increase. Yeah. Question 1 part finished. देख लीजिए. Now, second part. डायग्राम बनाने की जरूरत नहीं है इसमें. 1 mark. This explanation is good enough. Output second part. Output characteristics are controlled by input characteristics in common emitter transistor amplifier. Output characteristics are controlled by input characteristics. Input current variation, change conductivity of base, conductivity of base. This change of conductivity, this change of base conductivity increase collector current, increase collector current. Transistor amplifier. 2A larger amount of voltage due to large battery and large resistance. This is sufficient, good enough. If you want, you can give the formula for voltage amplification of voltage, that is IC upon IB into R output upon R input. Okay, this is part 2. Now part 3. LEDs are made of compound of the semiconductor and not elemental semiconductor. In any semiconductor, when we apply the circuit of LED, what happens is, due to recombination of holes and currents, the energy is emitted. That part we will write first. Due to recombination. और सोचिए क्या होगा उसके बाद? Due to recombination of holes and electrons, energy is emitted with frequency. Frequency is how much? Energy is equal to h nu. Therefore, nu is equal to E upon h. What is this E? This E is equal to energy gap. Now, this nu has to be of the frequency of light, which is quite a high value of frequency. For that, energy gap has to be high. We will write it. For nu to belong to light frequency, which is quite high, we need Eg more than 2.6 electron volt. More than 2.6 electron volt. Now elemental semiconductors have Eg, which is less than 2.6 volt or less than 2.2 volt. That will be around 1.6 electron volt. So they are not sufficient, but compound semiconductors, they have Eg which is more than 2.4 electron volt. This is gallium arsenic. So therefore we have to use compound semiconductors, and silicon and germanium, which are elemental semiconductors, will not give the light, and this will give the radiation which is a radio wave radiation but not light radiation. And what we need in LED? Light. Therefore, we have to use higher energy gap, which is for the compound semiconductor. Okay. I will make a bit correction here. What we need is more than 1.8. 1.8 or 1.9, which are gallium arsenide. Gallium arsenide phosphide. And this Eg is less than 1 electron volt for silicon and germanium. And what we need is more than 1.8. Therefore, we have to use gallium arsenide. And the main thing is to understand that higher energy gap gives higher frequency, and that frequency is in line with the light. That's why only silicon or germanium, which are elemental, cannot give that much energy, because their energy gap is smaller. Thank you. Over long distance. This is a 3 marks question, 1.5, 1.5, and 3 marks we have to complete in maximum 1 page, less than 1 page. Okay, so first write the factors that prevent a base band signal. Base band signal is a low frequency. Base band signal is a low frequency सिग्नल. हम बोलते हैं उसकी फ्रीक्वेंसी 500, so that is a low frequency signal, that is a base band. Okay, what is the problem? Okay, factor number 1, low frequency, low power. Cannot go to far distance, and use the technical words. What does it get? It gets weak, and what do we call that? Okay, so that is attenuated. Attenuation. This. Number 2, the antenna requirement. The antenna required is lambda by 4. For low frequency, lambda is very large, hence not practical. वेरी लार्ज के साथ आप चाहें तो ऐड कर सकते हैं किलोमीटर्स, हेंस नॉट प्रैक्टिकल. और अगर एंटीना नहीं है तो ट्रांसमिशन नहीं होगा. थर्ड, ओवरलैपिंग ऑफ नियर बाय स्टेशंस. Because it's a low frequency, within the low frequency range, many stations will have to work together nearby, and they will overlap. Nearby transmitters. Overlapping of nearby transmitters signals due to small range. Due to small range of frequency. Yes. So these are the 3 reasons why a baseband signal is prevented to be transmitted over long distance. This is good enough. Then second part, what is to be done to overcome these factors? Draw a block diagram to obtain the desired results. What is to be done? We will write here. All these 3 are due to low frequency. So we convert signals to high frequency signals by modulation. And this word should be very prominent, because this is what the examiner want to know, whether you know that low frequency to high frequency is known as modulation. By modulation. Okay? That is combining low frequency and high frequency. Then you can add up. There may be 3 types of modulations. You know that: amplitude modulation, frequency modulation, and phase modulation, and make one diagram. Only one diagram, that is amplitude modulation. Amplitude modulation diagram. That diagram you know, and that will complete the answer. It is more than sufficient for 3 marks. Now we go to the next question. Read this question. What we are supposed to do: suggest another activity. Draw a label diagram showing 3 magnetic. Suggest another activity. ये क्वेश्चंस ऐसे होते हैं जिसमें हमको बहुत सोचना पड़ता है, एंड इट्स वेरी वाइल्ड. इसका कोई सेट आंसर नहीं है कि वो आप सेट आंसर लिखेंगे एंड यू गेट द मार्क्स. सो यू हैव टू थिंक ऑफ मेनी एक्टिविटीज विच आर गिवन इन योर एक्टिविटी बुक. वहां से आप देख सकते हैं. आई कैन सजेस्ट समथिंग ऑन दिस, कि किस तरह की एक्टिविटी और हम सजेस्ट कर सकते हैं जो अर्थ के मैग्नेटिक फील्ड का वेरिएशन दिखाएगी. अर्थ के मैग्नेटिक फील्ड में क्या होता है? नंबर 1 डेक्लिनेशन, नंबर 2 एंगल ऑफ डिप. ये 2 चीजें हमको दिखानी होती हैं. डेक्लिनेशन शो करता है दैट नॉर्थ ऑफ द अर्थ एंड नॉर्थ ऑफ द मैग्नेट are not same. Geographic north south and magnetic north south are different. ये dip क्या show करता है? That magnetic field is not parallel to earth. It always makes certain angle with the earth. क्या ये 2 चीजें हम किसी भी एक्सपेरिमेंट से दिखा सकते हैं? अगर दिखा सकते हैं, we will write our story and that will make the answer for this. इसी तरह से ये टॉपिक हमको सजेस्ट करता है, ये हमको लीड करता है रिसर्च के लिए, ये दिखाने के लिए कि क्या हम कोई एक्टिविटी इससे रिलेटेड बना सकते हैं. सो आई विल सजेस्ट यू वन फॉर दिस. ओके, द एक्टिविटी इज वी विल पुट ए पोल इन द ग्राउंड, पोल ऑन द ग्राउंड एट 10 AM. वी विल टेक इट्स शैडो. 9 o'clock, if this is east, this is west. 9 o'clock, sun is at the east and shadow will be here. 9 AM. 3 o'clock, sun will come on this side and shadow will be here. 3 PM. The shadows are never in one line except for few days in a year. You will get it like this. Make this angle, make half of this angle and this direction gives geographic north. Geographic north. Now I extend this and this gives geographic south. So this is the way how we can draw on the surface of a earth, on the surface of ground, geographic north and geographic south. Then we take a magnetic needle and with the help of that magnetic needle suspend it When we suspend it, it stops in north-south direction, and we will take that direction. Sorry, this is what? Pole. Now, magnet, when we keep, the magnet gives us north-south direction like this. So this is magnetic north. This shows, we will write it. The two directions are different and they make certain angle between them. This angle shows that magnetic north pole is different than the geographic north pole, and by the years this angle goes on increasing. We can also check at our home that this angle is changing. That shows the north pole is moving away. Magnetic north is moving away from the geographic north. This angle is known as declination. This is an activity which shows element of magnetism in the earth. Other activities, find this magnetic north-south direction and put a magnetic needle. This was activity 1. Activity 2. In magnetic north-south, suspend one magnetic needle, free to rotate in vertical plane. This is important. Free to rotate in vertical plane, and we see that it stops in a particular direction, and that direction is this way. This is not horizontal. This is horizontal, and this is needle, magnetic needle, and we find there is a certain angle between the two. This angle is known as angle of dip. And this shows, this confirms that magnetic field of the earth may not be horizontal. The actual magnetic field always makes certain angle with the horizontal direction of the earth. We call it dip. Based on these two activities, we can draw, this is angle of dip, this is magnetic field due to earth, and we can make two components of it. One component in horizontal direction, we will call it H, and one component in the vertical direction, we will call it B. V, vertical. Or we can say it is BV and this is BH. So earth has got magnetic field which has got a particular direction with reference to horizontal. And here we know that BH is equal to B cos angle of dip, and B vertical is equal to B sine angle of dip. Okay, and tangent delta is V upon H. So this is the relation. Draw a label diagram showing three magnetic elements of the earth. So this is diagram 1, this is diagram 2, this is diagram 3. These are showing three magnetic elements of the earth, and we have given details of our activity. So this is 4 marks question, but this is one story I have given. You can give any other story, and that is what the examiner wants to examine. He would like to judge whether you are really think of any something which really leads to certain conclusions. Thank you.